Welcome back. We're still in section 1.3. We just got done covering the scientific method, where we looked at making observations, forming hypotheses, experimenting to try to prove your hypothesis as being true or false by setting up some type of system where you manipulate some variables and watch others respond. You collect your results in tables, graphs, and perform calculations, and then you draw conclusions based on those results that answer your hypothesis question. Now, we did say that a hypothesis is an educated guess because that's pretty much how it is defined in many textbooks, and you probably had that definition in middle school. We used to do the live lectures, I'd always ask, what's a hypothesis? And everybody raised their hand and say it's an educated guess. Well, what does that mean? Is it just a wild guess from smart people? You know, you have a degree and you can make a guess, and that's what a hypothesis is. Well, that's not actually what this thing is. And so we want to clear up a misconception about what a hypothesis is. So I'm going to scroll all the way down here. We also want to talk about how that ties into a theory and a law, because a lot of people, they say, I have a theory about, such and such of an event, or I just have a theory about this part of life, or whatever it is. Well, what do they mean by that? Well, here's a common misconception. Oftentimes, and sometimes you're even taught this, they say that a hypothesis is just a guess. It's an educated guess, but we'll just put it that it's a guess. You're pretty sure, or you're actually not even that sure. You're just guessing at that point. And then after lots of experiments, we upgrade it to a theory. So now we're pretty sure this is true. Not 100%, but we've been experimenting on this a long time, so we're pretty sure we got this thing right. And then after so long of experimenting, it happens every single time, we call it a law. So now we know for sure. We write it in stone. And so it is a graduated process of going from you're just guessing to you're pretty sure that it's true, and now you're absolutely positively sure that this thing is true, and now we call this thing a law. But unfortunately, this is completely wrong. We'll put a frown by it. That is not correct at all. So let's try to clear this thing up. So here's the reality on a law, theory, and a hypothesis. First of all, a natural law, and I just got a law written there, but you could say this is a natural law. Laws are just summaries or statements of generally observed phenomena. For example, there are gravitational laws. That when you do the calculations, this is how objects behave. Why? Well, we'll get to that later, but this is what we see all the time. There are gas laws that we're going to be studying in the second part of chemistry. Gas laws. They describe, or they say how gases behave. There is a common law that you probably learned in middle school. We're going to tackle again early on in this class, called the law of conservation of mass. That says mass is neither created nor destroyed. It can only change forms during a chemical reaction. All right. So those are laws. They're statements of what we see. Now, a theory is an explanation of how or why things behave the way they do. Or we'll just say how or why phenomena occur. If you're not familiar with the word phenomena or phenomenon, all we're saying is how or why something happens. A phenomena is just whatever is happening. All right? So this is the how or why, where the law is the what happens. I guess we want to write that. This is what happens. This is the how or the why it happens. For example, gravitational laws explain how, what we see. But Einstein's theory of relativity looks to explain why gravity works the way it does, why planets move the way they do. Has to do with, uh, uh, disrupting or changing curved space-time, the fabric of time. All right. If you want to learn more about that, you'll have to take a physics class. But his theory of relativity looks to explain how or why gravity works in such a way. Gas laws are explained by using what's called the kinetic molecular theory. It's a it gives 4 or 5, depending on your textbook, 4 or 5 points that say this is what gases are, this is how they behave, and so because this is how they behave, this is why we see the gas laws working. And then when you try to take a look at the law of conservation of mass, we try to explain that by using what's called atomic theory. Atomic theory. And we'll talk about that in the next chapter as well, or in the coming chapters, where John Dalton said this is what atoms are, and this is what compounds are, and this is what happens during a chemical reaction, so therefore mass is conserved. Now, if you're not following that, don't worry about it. We're just saying that theories explain how or why these occur. And then finally, the hypothesis, we call it an educated guess. I like to call it more of a prediction. A prediction based on theory. That's why it's an educated guess, because if you think something happens for a particular reason, you could predict that something else could happen. For example, as Albert Einstein explained why planets move the way they do and why gravity works the way it does with his theory of relativity, he also came up with his equation of E equals mc squared. And he predicted that if you split the atom, in essence, if you split the atom, some of that mass will be changed into energy. So he predicted atomic energy. And I'll say atomic energy based on E equals mc squared. If you've ever seen that equation, it's one of the most famous equations. But that was a prediction based on that. Also, we'll stay with Einstein's theory of relativity here. He also predicted that you can actually bend light. If here is our sun, here's our sun, and here is a star that's behind the sun, and here's us standing on Earth. Here's me with a beaker or a flask. There we go. So I'm doing chemistry experiment. What he predicted is that if normally I could not see the star, the sun would actually bend the starlight so that I actually could see it. And they actually proved that in experiments. He predicted that ability. So again, hypotheses are more predictions. Now sometimes there's a lot of gray areas to what constitutes a theory and what constitutes a hypothesis, but in general, theories are very robust ideas that can explain lots of different things. They try to connect lots of different phenomena and show why lots of things work. Where a hypothesis generally is looking at one individual occurrence and trying to predict why that's happening, or making a prediction that you should be able to do something based on your theory. So hopefully that clears up that misconception that this is not a graduated type of situation where you go from guessing to pretty sure to knowing for sure. Laws are what happens, theories are how or why they occur, and hypotheses are more predictions. That concludes this chapter. We're not going to be doing section 1.4, which deals with problem solving. We're going to be doing enough problem solving as it is, and we'll explain that as we go. We'll see you next time.